Good afternoon, everybody. My name is Ismael Vasquez. I'm the technical sales manager with Carmelo. They will be speaking about the retaining walls. We have a license in Puerto Rico to make the Keystone blocks, and we've been making blocks since 1955. So, what is a retaining wall? Retaining wall is used to contain soil and hold it in place in areas as slopes and drops of land. Retaining walls can be used to delineate courtyards, entertainment areas, create pathways, residential courtyards, and they can also be used to reclaim and constrain soils to form usable pathways. And again, these blocks are very architectural. That we comes in several colors, so it beautifies the area as well on that retaining wall. It's also almost maintenance free because all you need to do is power wash it every once in a while, and you don't need to paint it, but you can do clear seals on them as well. So Keystone's blocks, we manufacture them in Puerto Rico, and they come in a variety of styles. They have three planes, they have straight faces, and so they do. We can do it for retaining walls or decorative walls. Okay, as you can see here, and we also have the country manners. You can do steps as well. You can also do steps with the Keystone as well. Keystone blocks, the compact. And so there's several things you can do with them as well as retaining that wall. They come in two different styles. The Keystone Standard, they come in tree plane and also straight split. So it's a straight face. And these blocks weigh about almost 100 pounds. Okay, so they're 18 in height and a width about a foot and a half. So you have a 1 square foot. So let's say if you have a retaining wall about 400 square feet, then you use 400 blocks of these, right? So these blocks can be used for retaining walls from, let's say, 5 feet to almost 60 feet high. I mean, if you're using the compacts, you can go up to 60 feet. And if you're using the standard, you can go all the way up to 80 feet. And so they're very easy to use since it's one step after the other. So there's less construction barriers there as well. It uses a geosynthetic where it'll give you with the shear stresses between the units, right? And Keystone has some tables where you can select, depending on the height of that retaining wall, you can select if that geosynthetic is going to go every 2 blocks, every 3 blocks. Okay, so the other type of block we have that the first one we just discussed was the standard. Now this one is the compact, which is a little bit smaller. It's 8 by 18 by a foot. It has a 12 inches of depth. Now the weight of this is about 76 to 81 pounds. And it also comes in 3 planes. It has 3 sides there on that face. And also it comes in a straight split, which is all straight. So again, this is a very cost-effective construction, and it's very easy to install, starting from the base. And the compact, again, it's about 78 pounds. So once you start laying it over the base, you just keep going one by one, installing these. And I'll explain how we do the installation of these compacts. One other elements that we also use are the let's say the pins. They're like fiberglass pins. As you can see here on that small screen, right? They're fiberglass pins where you're gonna put them spaced out like a foot in between the blocks when you lay them, right? And these are gonna hold the mesh. It's a mesh where I'll explain in a minute how we place it, right? So that's what's going to help you with the shear strength of that retaining wall using this Geogrid reinforcement. So it has very high flexural strength up to, let's say, 64 psi. So the first thing we use is the stone. It's a 3/4 inch stone, and this is used to help in the drainage. Usually we fill in all the holes of the block and in between gaps between these blocks. And also you're going to be putting a foot behind the blocks as well with this 3/4 inch, helping the helping the drainage of water and creating less pressure of that backfill. Okay. Um, so it increases the resistance of the connection, and it does not require mechanical compaction. Once you lay that aggregate over, you just keep laying it one over the other. Let me go back here. The main thing is that you put those pins in before you place the aggregate, so the holes don't fill with aggregate, right? So you want to make sure that, and if that unit comes in without any holes, like you can see here on the one that I'm holding, if it comes out without any holes, you try to hammer them down in the area where it's marked, and sometimes they get filled in the plant. Those holes, but the holes are there. So how do we install the Geogrid? Um, the Geogrid has a seam. You can see here, it has a seam. Then the strings that are thicker are going to go perpendicular to the face of that block. So this is the face of the block. So the stronger side of those strings are going to go in from where the pins are all the way back. They can be like 5 foot, 6 foot, 7 foot, 9 foot. All depends on the design that is required. Again, if you have a retaining wall over, let's say, 6, 7, 8, 10 feet, you need a design by a structural engineer. And he will have a drawing of how he wants these keystones to be placed, right? And so there's a difference between some of the blocks that are made out there and the ones that are made by Keystone with the pins. The walls with anchors and mechanical connection bolt is recommended for all walls greater than 3 feet high. I mean, you can go with a compact up to 60 feet. And the great thing about using these pins is now you have these connection and also the mesh, and that will be creating a mechanical connection every time. So if you use, let's say, some of these blocks that are out there, they're called the gravity blocks. The problem with those is that it has a teeth at the end, and if there's, let's say, movement, uh, those blocks can move because there's no interlocking like when using pins. Okay? So usually these blocks are used, or the Keystone compacts and standard are used for, let's say, retaining walls that are over 3 feet. We make garden walls which are 30 inch up to 30 inches, and they're smaller units. sometimes we have customers that want to use these big compact or to use them around, let's say, garden as well. I mean, you can also use them as well, but there's also garden blocks as well, garden wall blocks that you can use. And but again, if it's over 3 feet up to 60 feet, you can use the compact for that retaining wall. So some design information. So this is how the retaining wall is going to look like, right? We start in the bottom here with the leveling pad. This can be crushed stone with soil. And you compact that with a cylinder, right? Or and you want that very leveled on the bottom, right? Or you can also use a 6-inch concrete pad. It doesn't have to be reinforced, right? Minimum, let's say, or let's say 2 feet or 3 feet, let's say, depending on the design, right, of that, how that engineer wants it, right? And one other thing, it has to you have to have at least 2 blocks of the Keystone underneath the finished grade, right? Here, you can see on the bottom. So you have to count the 16 inches that's going to be part of your retaining wall. And then let's say you have 10 feet high. So this would be 11 inches, 11.3 inches, let's say, total of height. If you have over the surface 10 feet, right? So these blocks can be either recessed an inch, depends, or you can go to a straight line, okay? And they can be vertically installed, right, in a straight line, okay, instead of doing it recessed. Behind these blocks, again, we need a foot of 3/4 inch aggregate, but on the bottom you're gonna be putting a drainage collection pipe. It's perforated pipe, let's say 6 inch in diameter, and you can also use a filter fabric so it doesn't fill up with soil. So here you see the first line of geosynthetic. Then you go up three blocks. Then you see another line of geosynthetic, right? But when you start the first line, the idea is you start with the leveling pad. You put your first block, and then behind that you put your foot of 3/4 inch aggregate, filling the block as well, and you'll be compacting that first row of block, right? You compact it with a damper or roller, depending on how big the area is. And so you go one block over the other and be doing that, right? Um, then your second block, you put more aggregate, then more soil, you compact it till you go up to like that fourth line where you have the geogrid, then you put that grid. Then on the top, you know, your finished grade, right? And that's how you're going to finish it. So there's 2 types of walls and situations. One is where you want to fill the wall, okay? You have your land there and you want to gain some land on the top, okay? So you're filling or adding soil in that area, and then you put your retaining wall there with let's say the meshes. Um, then the other side would be if let's say you want to gain terrain on the bottom. So here you have the existing grade. You would cut into the land, right, and put your keystone blocks. So now you're on the bottom. You're going to have more space. There's several types of soil, and the first one, let's describe this. The first one is like a sand gravel. So the soil particle grains are visible. There's only a small fraction of clay or silt. It drains freely, so the water does not soak on it, but filters through. And if you try to make a roll on your hand, right, particles are kept separate. Right? So that's how you to determine if there it's sand. Not, if not, you need a professional there to visit and tell you what type of soil you have, right? Um, the second type of soil is a sand lime, and it has a friction of 30 degrees of feet, and is the material in the transition between gravels and clay, and it's difficult to detect for these reasons. In general, it looks like a very fine grain sand. It still retains granular qualities, but also retains some water. So the water drains very slowly. And then finally, we have the sand and clays that has a friction about 26 degrees. If you rub the material on your hand, it will form a wet ball. Soil particles have a very fine texture. These floors retain moisture and have little internal friction, which increases the pressure action on the wall. So again, you have to determine what type of soil you have to determine what type of design uh, you need to make the retaining wall with the keystone blocks. And here's one of the tables that Keystone provides. We have a manual that we can also you can either go into Keystone and go to their site and download that manual. If not, you can send us an email at info@carmelo.com and we'll send you the manual. And they provide you with certain designs here or construction of these walls to, let's say, 4 feet to 11 feet. And here they depending on the soil you have, let's say it's a silt, right? You have 26 degrees, and let's say your wall is about 7 foot. So here they tell you that every first two blocks you have to put a geosynthetic mesh, let's say 6 feet, 6 feet behind that wall. Then the next three blocks you're gonna be putting your geosynthetic. Then the other three. So this is how the table works here. So the first case here, it does not have any surcharge, any load on the top. So let's say you're putting a structure on top here and it has 250 pounds of surcharge, pounds per square foot. Then you come down to this case two, and you see here that when it's let's say 7 foot and over, you're gonna really need an engineer to design these walls. Okay, so that's very important. Uh, and then you see here on the right, if you have a sand gravel with the friction factor of 34 degrees, okay, then for that 7 foot retaining wall, now here see the geosynthetic is like a foot less. It's 5 instead of 6, okay, and so on, right? So that's how the table works. So those engineers out there, and Keystone has a program which you can download from their website, and it only costs $10. And with that program, you can design, and they also have some videos in where you can get some training on how to use that program as well. So let's talk about the Geogrid 3x7. This is the one that we always specify for a 12-foot high wall. Okay, so this is the mirror grid, and so the dimensions here. I mean, they come in rolls about they're 6 foot by 150 or 12 foot by 1,000 feet. Okay, and that's how you then do the estimate of how much say mesh you'll be needing. And but this is how the mesh looks like. Again, that's a seam where this is going to be perpendicular to the face of the block, and then the thicker strands, right, are going to be where it's going to go from the front to the back of that wall. So that's where it's going to pull and do that friction uh, and hold up that wall, okay, with that mesh. We can also do terrace where you can let's say if if the height on the bottom H1 is times of the terrace, then you really don't need like a lot of design for that, right? Um, but if you're at the height of the bottom, right, H1, it's less than uh, the height of that second terrace, then you're going to need an engineer to design that terrace for you. Okay, that's some basics on that. But you can divide your, let's say, retaining wall in two or three, depending on the slope and hill you have. So how does this geogrid work? You can see on the right, we formed a with we formed with aggregate, right? And we have somebody step on it in that form, and we took out the form, and you can see how the segregation was there in that right picture, right on the top. But when using layers of the geogrid in between that form, right, in aggregate, you can see how this we took out the form. You can see how this geogrid is working. It really interlocks that aggregate as well, and also the soil. So how do we install the Keystone blocks? First of all, we excavate, base trench, okay, and um, and and then we'll have a, let's say, a finished, let's say, soil. That's where you're going to be there, and so you'll have a width of that base, okay, and then here you can see the depth where again the first two blocks have to be on the underground, and then at this surface here, and then you start your wall. Here here's a section where let's say you have a hill and you're putting your blocks, and you can do steps with, let's say, the base. Okay, this would be your base, and you can do it in steps, and then you install your blocks. You got to make sure that that they interconnect uh, with each other, like halfway in those steps. So I have let's say contractor that say that's easier to do it with the compacted soil and aggregate for that base instead of doing it in concrete, and then but again, you can also do a 6-inch base with concrete to do those steps. That way you maintain the horizontal on those blocks. So here they're distributing on the left here, they're distributing the leveling pad. Okay, you got on the right picture here, he's using a level just to make sure that the base must be leveled before you start putting any blocks, and also compacted. And here's a leveling pad with concrete without reinforcement. So here, this is the slope going up, and you can see how they built the pads, right? The concrete pads in steps here. So once you have your base or you leveled, right? You install your blocks. These are the standards, and you put your level in between the two blocks. So you want to make sure that that's leveled, and also you do it perpendicular to the face as well. And you want that real leveled as well, okay, before you do anything. So whenever you're working with the with, let's say, hills, you have to have at least start with two blocks from your next steps, like you see here. Okay, and after you level the block, you put in your pins. Okay, pushing them in those holes. Okay, and they should be spaced out like a foot already. So that comes from the factory, the holes. Okay, then you pour the 3/4 inch stone over the blocks, and they're going to be filling all those holes, the cavities, and then you'll also have a foot behind the blocks as well for the drainage. So you got to make sure you put that pipe on the bottom first, perforated pipe 6 inches, and then you put your 3/4 inch aggregate. So once you put your aggregate, then you put your soil backfilling. Okay, and so you'll be doing the first block the first row of blocks. You fill the aggregate and the foot of aggregate behind, then you place the soil and then you come back and compact it. And you got to make sure that once you have your meshes there, you don't use a truck excavator over them. I mean, the trucks that you can use must have either rubber wheels over these construction. Okay, because then you'll ruin the geogrid. You can see here they did a couple of layers already. And again, it's one step after the other, putting the block, filling it, putting the pins, putting the aggregate, and then doing the filling of the soil, and then compacting it, roller or damper. Before we go to the next level of block, you have to make sure that all the aggregate that's over all the edges of that block is taken out. You sweep it out, okay, and just clean that surface. If not, then your blocks will be not leveled for the next layer of blocks. Here you can see the geogrid. The two pins here. See the uh, thicker strings going down from the face of the block down. Okay, and you can see the seam here that's identifying how you're going to put that geogrid. Okay, so you got to make sure that the stronger strands are connected from the front to the back. Okay, and you can also put some stakes on the end here to straighten out the mesh. Okay, it can be wooden stakes. If let's say if it's a bigger job, a bigger let's say retaining wall, and they want to use steel meshes like in highways, then you just have to lay the steel over the two pins, and no need to anchor them on the other end. So the only equipment with wheels on the reinforcement, again, that's very important. Then you're ready to place and align the following blocks after you do that. Okay. You can see, I mean, there's about 78 pounds each. So, and they're staggered in between the lines. Okay. So we adjust the leveling using the material such as asphalt. So here, what they're saying is that you can even use the mesh. So let's say make a shim. Let's say you need to um, level some edges of that block because if it's not horizontal, so you can take that mesh and twist it and make it thicker, or let's say or 4 times thing like that, and then you can make a shim there and help you level. So you can use asphalt shingles, a piece of coil mesh, or a vinyl slab as well. I want to make sure that you use something that doesn't rot, with time. Uh, so you always verify the alignment of that wall as well. You can put a string on the front as well of this wall just to make sure that we're aligned. And You want to level these blocks every line. So some installation details. Here you can see these are the standards on the left here. Okay, and whenever you're putting, let's say, pipes, you can cut the block and adjust the length of those blocks and then put them one next to the other to the pipe, right? So you can put pipes, those culverts and things like that, and that's how you place these pipes. Yeah, we had a recent project where they wanted to install a pipe after the wall was installed, and what they did, what we recommended was to take every line out again from the top to the bottom in that area, and then put the pipe, and then this is how you would adjust each line, just cutting the sides of those blocks. Okay, some more photos there on how to install these pipes with the blocks. So, and you can also have a gigantic pipe like this tunnel, steel tunnel like this, and again you can uh, put these blocks right next to the whatever structures you have. So you can do curves, let's say guardrails as well. Um, and if you have, let's say, a 90 degrees inward, you can do that installation. The main thing in the bottom is that you this would be the way you'd be connecting. Say no pin in the overlay unit. So that means you're not putting any pins here. These two on this corner. Okay, so and then when you come up with the next one, the next layer, this is how you be installing them. So then you have walls with changes in directions, right? So so again, how you be placing one layer after another to do these 90 degrees angles. Um, uh, in our case, we don't make the let's say for corners, we don't make uh, square blocks. This would be you would have to do, let's say, a concrete column, or use a concrete country manor block to work something like this in a corner like this, right? But you can also use the uh, the keystone blocks to do steps. Okay? And then you can use the cap. The cap is like 4 inches high. It's the same texture as your keystone. So and that's how you're gonna hide these holes or cavities with that cap on the top. So you can do the curves convex as well. Okay. See here, it's convex. And this is how you lay them. Concave. And if you're doing steps, okay, so we can share these diagrams with you as well with all these details. Um, placing additional keystones and how you can be doing these steps and putting the cap on the top is your final step there. You can put fences behind the retaining wall. Let's say they should be like 1.5 feet behind. So these guardrails, say in the highway, or if you're putting a fence, would be like 1.5 feet behind this retaining wall. This is a project we did in San Juan, and this wall has about 60 feet, and so it is over 25 years already. And you can see here that the seawater is hitting the retaining wall. And we have inspected this wall, and it has lasted there all those years without any problem, without any erosion. Okay, you can see how they built the fence behind let's say the keystone wall. Okay, so there's a fence there, so just to make sure for safety hazards. So how do we calculate how many blocks we need for a wall, right? So we know that our keystone block is 1 square foot. It's 8 inches by a foot and a half, right? And we're going to need 2 pins per every block, okay? So we have a formula here. You see it here on the right. This would be your H2 and H1, the height of that wall. So if let's say you have 2 and 4, you have to add those two and then cut them in half, and you have an average of the height of that wall. Okay, so but you're also including the two lines that are underneath, which will be 1.33 feet. Okay, underneath. So the length of that wall times the height plus the height underneath the soil for those 2 blocks, that would be your area. Okay, so for a wall, let's say 100 foot in length, with a height of 10, and let's say H2 is 2, so it's coming from 2 to 10 feet. Okay? And then you have a foot, 1.3 inches, with 2 lines of blocks underneath the soil. Okay, that if you do all that calculation, right, you're going to have that you're going to be needing 733 units. Okay, so and that means that for that 100 foot of a wall, if you divide it by 1.5, which is the length of that unit of block, then you're going to be using 67 caps. Okay, and then if you multiply the total, let's say total blocks times 2, then that'll be the amount of units. So your average cost of these let's say units will be like 880 per square foot. Okay, but then you also have to calculate the amount of mesh, right, that you're going to be needing. So here, let's say if the mesh you'll be needing is 12 feet by 150 feet roll, right? There's 200 square yards. They may cost about $500 to $600 a roll. It's about 28 cents a square foot. And then for 3/4 inch stone, you'll probably uh, spend about $20 per ton. Okay, and then you have to calculate how much aggregate you're going to be needing to fill the blocks in that foot behind that wall. Okay, so where I'm hearing is that for installation, these walls can be from $20 to $50 a square foot. I've heard of other contractors with $12 a square foot, depending on the size of uh, of the of that wall and the complexity. But the bigger the wall is, the more economical should, in terms of labor, should be. Right, so it'll dilute on that on the cost. So I really appreciate your time, and now we're open for questions. So if you need any, we can share this presentation with you. If you send us your email, we can send you a PDF. You can write at info@carmelo.com, and they'll send you a PDF of this presentation, so you can take it. Well, I mean, you really have to have some experience, but we have, let's say, some layouts that we can share with you on how to do it. So like if you let's say have curves or make it rounded instead of flat, that wall. Again, in the Keystone manuals, it shows you how to lay these uh, these blocks whenever it's not a straight line. And Roberto, in North America, there's other manufacturers out there of Keystone blocks. In Carmelo, we just cover the Puerto Rico and the Caribbean. We can send out our blocks to the Caribbean, but in the States, there's other manufacturers that have the license with Keystone. So for those engineers who want the program for the design with these retaining wall blocks, Keystone blocks, you can go into the Keystone website and download that program for $10. They'll send it to you. And again, they have videos in YouTube where you can learn how to use that program as well. Okay, so the Geogrid is supplied by JM Caribbean in Puerto Rico. We if you need the information, you can write us at info@carmelo.com. We'll send you the phone number where you can contact them. They also do designs as well with the Keystone blocks. But we also have other engineers in Puerto Rico that design with the Keystone blocks that we can also refer you if you need a design for your retaining wall. I think you guys all good. I don't know if you have any more questions. If not, I'll resume the webinar. And I really appreciate your time. Stay tuned in our website, carmelo.com, for our next webinar. And we also have, let's say, training in Puerto Rico for the structural concrete insulated panels. Our next workshop is going to be on the 9th of November. So it's a Saturday from 8 to 11, where we'll be explaining how to install the structural concrete insulated panels to make, let's say, houses, buildings up to 4 feet. And we also we'll show you how to use our MTech machine, which is a mortar mixer and pump, where we shotcrete, say, with low volume, these walls, and they're very fast. I mean, the system is very, let's say, construction, let's say, ability to do, let's say, structure, let's say, about 1,000 to 2,000 square feet in a day. You can lay some panels and then probably put the mortar in about 1,400 square feet. So you really move real quick with these systems. And that's the structural concrete insulated panels. So thank you very much, and have a great afternoon.